Good morning. Does anybody know who this gentleman is up here? I knew you'd know, Donnie.
That's Michael Phelps.
That is Michael Phelps, and what is he famous for?
He is famous for winning 8 Olympic gold medals at Beijing Olympics, and he also has the record for the most Olympic medals of all time.
Awesome. Very good. I take it you're a swimmer? A little bit? So if you were going to swim in the 2016 Olympics, what would you need to know about Michael Phelps?
Not need to know anything because he's retired.
Has he really?
He's done swimming. But his mom is probably going to force him to make it, so he's probably going to swim a little bit, but
not like normal. Okay, so if you were still going to be in the 2016 Olympics and you wanted to win a medal, what would you need to know? Shelby.
The average speed he usually goes, and you want to have to try to beat his speed by practicing and trying to get faster.
Awesome. You would need to know how fast he speeds. So you want to maybe predict how fast he's going to go so that you would know how fast you need to swim. That's kind of what we're going to do today, but we're going to be looking at the 100-meter dash, or the men's 100-meter dash, okay? I'm going to pass around some data for you, and it's got the times, the speed that men have run the 100-meter dash from 1900 to 1996, okay? Once I give this to you, I want you to think for a few minutes all by yourself, some private think time, okay? Think about how you're going to graph this, okay? Think about your X and Y axis, think about your labels, think about everything, okay? And then after you have some private think time, we're going to do this in your groups, okay? You're welcome. There you go. Okay, talk a little within your group and decide how you want to set up your graph, how you want to set up your scatter plot, and then on the yellow piece of paper that's on your table, I want you to graph the scatter plot for me. After you've graphed your scatter plot, I want your group to come up with the best correlation coefficient you can get. Estimate what you think the correlation coefficient's going to be, okay? And let's go ahead and round that to the... Let's do the thousandths place, because we want to have a winning group, because you might get a little surprise if you're the winning group. Okay?
All right, I'm going to put the year of the Olympic Games as X, and then since that's an independent variable, well, no, the Y is, put Y as the winning time. And then, yes.
What should we go by?
What? We're going to go by the 1900s. It's going to be way easier. We go by 1900s. Like, instead of doing what we did yesterday, we're going to do.
I'm talking about our scale though, like, because are you on these? Yeah.
I would do like 9.8.
For this one, we should easily go by 12 or 1900. Yeah. This one, probably, by 0.2s or something. Maybe 0.4s.
Can we do like exactly the year like that?
Sure. If that's what your group wants. Just make sure you label. And I want one of you to do it on the yellow, okay?
It's not starting at 0.
Perfect. What's that called?
The break.
I call it
The
squiggly
break.
thing, but
It's a good one. The technical, the break, squiggly thing. I knew what you meant, right?
9.6.
Good job. What scale did y'all decide on?
10.
Yours at 0. Awesome. And you're going to do tenths. Okay.
We're going to do a break and start at 9.8 and
Perfect.
then go up.
Sounds good. Christian, we're going to do the calculator later, okay? Help them with that graph. Y'all think about this graph they're all doing.
For the years,
Mhm.
did you, like, do we go from tens? Could we do that? Or do you want us to literally write 9 to
Nope,
12?
you can do whatever you want.
Okay.
Just remember you're going to type it in the calculator eventually. But no, you can count by anything you want.
Okay. And it goes up to 11. So is that okay?
I would actually see how it puts 0.0. So when it says 10 and 11, I mean, it's the same thing, but
Yeah.
just to make it even. And then
We're gonna label up the 1900.
Did y'all decide on a scale?
Yeah, we're gonna go by 12s on this one. We can't really
Okay.
figure out like what.
Because we have to go about like 116 units to do that, so
Okay. So where do you want to start, maybe?
9.84.
You start at the exact? Okay.
Or maybe a little bit before.
Can you do a
9.88.
squiggly line for the x-axis?
You can. Do you need to, though? Do you need to do a squiggle? What's that called? Squiggle. A break? Mm-hmm. Do you need a squiggle on the X, or do you need a squiggle on the Y?
Why?
Maybe the Y, not the X? Mm-hmm. Y. What are you going to start with on the X?
9.80 or something. Maybe.
No, on the X-axis.
Oh, x-axis. Oh.
The 1900. So there's really no break there. Okay, but you do have a break on the Y-axis. Good. Good, good, good. And you've got a good label. I'm going to pass around some questions that you can use to help make sure you're on the right track. Okay? Just a few little questions to think about as you're doing this. Yeah, absolutely. Okay. You can write on these questions if you want to. Just making sure you're doing that. We're going to do that in a minute, okay? Yeah.
X always B. Not times. Because it was.
Okay, tell me a starting point. Where could you start? Do you have to start at 9.84?
Start at 9.8.
Okay, you can start at 9.8. And you got to go to what?
11.2.
11.2? So, or 11?
Oh, yeah.
we could do
Let's go by 0.2.
Okay, perfect.
Okay.
As long as you're consistent, as long as you label, there's not really a right or a wrong.
Yeah, 9.8. I guess try.
And then think about these, okay?
Okay.
Wherever it goes, it goes. It doesn't have to do a specific thing. Okay? How do you know it's going to make a line and not a quadratic?
Wait, what do you mean?
Like, how do you know that's going to be a line that you're drawing through it? Can you tell that?
Because they're not all spread out.
They're not all spread out and there's no curve. It looks straight, right?
Right.
So that's how you know it's linear. Okay? Good job. Good
Winning
job.
time would be T.
Yeah, that's right.
Okay, so
Wait, what?
the winning time T up here.
And then years is
Between
Y.
T and Y. Yeah, we thought we were just going by the axis.
Yeah, so we could just put like
But like in
year is
parentheses, T.
But all have to do these questions on separate.
No, you can all answer together based on your yellow. So just have y'all done all of these.
We are going to right now.
And when you decide on your correlation coefficient, I want it on the whiteboard. But don't let anybody see it.
Or is that going to be on notebook paper or are you going
No, you can just do it right there. This is just making sure you've done everything. You don't actually have to write it.
Oh, all right.
Okay? It's just help make sure you've completed everything. Nice. Nice. Okay, tell me how you knew this was a straight line. There's no what?
There's no curve to it?
Perfect. No curve, so you knew it was linear, right? All right, have y'all estimated your correlation coefficient?
Did, like, would this be part of it though? Would we even look at this part?
That helps you decide. Remember, what's a perfect correlation coefficient, 1 or -1. So the more points away from it, or the farther away, the closer to 0. So you're going to kind of
Wait, so these
guesstimate.
these would have an effect on the line though?
Yes.
Okay.
Yes. Hey guys, how are y'all doing? Should I go through your questions?
Yeah.
Okay.
I'm maybe changing our prediction though, because she made a
Yeah,
mistake.
I made a mistake. I put it under 1020 instead of under. I mean,
Okay.
above 1020. So
But
it
still
might
like
be changed or-
it's still a strong negative
Oh,
correlation.
Yeah.
Okay.
I'm thinking now.
I'm agreeing with you.
I'm thinking now it's like negative 0.9.
All right, when you're set, put it on your whiteboard. I think y'all are good. You're a perfectionist at this table, aren't you?
Yeah.
Yes.
I like it. Nice. Okay, let's talk about what type of function this is. Does it have any kind of curve to it?
I can't see it. It's a
Because
Kinda.
you've got to decide what kind of function.
Linear.
You think it makes a line?
Yes, ma'am.
I would probably agree with you.
It doesn't really curve enough to make anything.
Make it anything different.
Yes, ma'am.
Yeah, because
So draw the line you think has the best fit to that.
Draw this line. Maybe connect this line and.
Nice, nice. Nice.
That like makes that correlation a whole lot.
And what is that one? What's that called? That one lonely point out there.
It's like outlier.
Good, Katie. Good, Maria. All right. You're all going to come up with your correlation coefficient. You want the prize, don't you? Yeah. Did y'all go through all your questions? Yeah? Have you come up with your correlation coefficient yet?
Yeah, we got.
Okay. Will you put it on your whiteboard for me?
Okay.
We're going to hold them up in just a second.
Yeah, that'd be bad. Then we'd be really off. Okay.
Okay, you have about 10 seconds. 10 seconds, and I'm going to ask for them. Yep, I want it to the thousandths. I want it to the thousandth. Okay, can I have everybody's attention up here? Let me see those whiteboards. Let's see what we've got. Negative 0.987, negative 0.974, negative 0.85, 957, 965. These are very, very good predictions. Who can tell me why everybody has a negative? Raise your hand. Marie.
The line is going down.
The line's going down. So if your slope's negative, your correlation coefficient's going to be negative as well. Okay, so somebody tell me who wants to show their graph. Riley, will you bring it up here for me? Just let me move this for just a second. Okay, set it right there for me. Let's see it. If it's going to show. We'll get there. We'll get there. Okay. So here's their group. That's pretty good. So you let your x-axis be years.
Yes, ma'am.
Okay, why'd y'all choose that?
Because it was an independent variable, and like how I had to explain it to my group, the time is dependent on the years, not the years dependent on the time.
Nice. Very nice. Very good graph. I like it. Katie, you want to show yours? Thank you, Riley. Take that map.
If you just did like by tens, is that what you meant?
Oh, I see. You did years, but they didn't do the exact year. They did their years by tens. Is that okay? Yeah, nothing wrong with it, right? As long as it's labeled, you're good. Anybody have something different? Parker? Thank you, Katie. Nice. Why did you choose to use 2 digits for your years?
It was just easier than writing out 1900, and it just kind of simplified it for you.
Okay. Awesome. Thank you. Okay, how can we check our graphs using technology? What can we do? Amanda?
You could use your calculator and do stat.
Awesome. Okay, let's do it. Let's use your calculators, enter your data, and let's draw our stat plots. Same thing there, clear enter.
Okay.
Okay,
Thank you.
you're welcome. Where do we go after we put in our lists? First we want to see the scatter plot, so where do you go? Remember? Zoom what?
What was that? AX.
Not yet, that's your regression.
Zoom stat.
Zoom stat, because all your data's in your stat. Good. Good, good, good. I see some of you started at 0. Some of you are using the full year. It's good options. Good options. Okay. Yeah, we want to graph first. Okay. Hey, y'all, look up here for 2 seconds. We've got some questions on graphing. Once you enter your data into your calculator, where do I go to actually see it on my graph? If I want to see the picture. Will?
Push zoom and then push 9.
Zoom and 9. And what is number 9?
That would be zoom stat.
Zoom stat, because we went to stat to enter our data. So zoom stat's going to show our graph. Why could it look a little different on the calculator than on your graph? The scale's different. The calculator's a lot smaller than your piece of yellow paper. So depending on the size that you drew. Okay. So how are we going to test our correlation coefficient? Where can we go to determine what it really is?
You click stat and you arrow over to calc and then go to the line registry.
We know this is a linear function, so we're going to do our linear regression. Okay, so do your linear regression and let's see who got the closest to their correlation coefficient. Who thinks they got the closest? Who got the closest? Y'all think y'all are close? Let's see what it really is. Did you get it? We did a stat, calculate, linear regression. Negative 0.974. Who thinks they're the closest? You got the exact one? Awesome. Guess what you win? How about a gold medal? You've already won your gold. Awesome. I apologize, but I can't sing the national anthem, and you probably don't want me to sing the national anthem. Okay. Who can tell me what else we can use this linear regression for? Ricardo.
To make predictions.
Okay, to make predictions. What data do we have now that we didn't have before? From your calculator. A prediction.
I'm not sure. Coefficient.
Parker.
The prediction equation.
Perfect. Absolutely. Prediction equation. So we can now predict future events. Now, do you think we're going to get the exact time? Probably not. Probably not, but we could get close using the data that we've already collected, right? Okay, I want you now to predict. Let me ask one more question. Does it matter if I used 0, 12, 24, 36, or 1900, 1912, 1924? Does it matter will it change my prediction? Will not change your prediction, but what will be different?
Your graph.
Your equation will be different. Your prediction equation will be different, but that's okay. If you used 1900s, what kind of year are you going to enter for your X?
The exact year that you give us.
Perfect. Okay? If I started at year 0, am I going to use the exact year? No, you're going to correlate that. Okay, let's try one. I want you to predict the winning time for the 100-meter dash in 2020. Okay, predict the time for the winning time for the gold medal in 2020. That's why you didn't have that. You're welcome. Are you rounding?
She gave us 2020.
X would be 2020.
So you do y equals a x.
So what are you going to use for
A
your
is
X?
32. No, a plus b times x. This is
120,
a.
perfect.
You have to have, is that exact?
What? Well, nothing can be exact.
I know, but is that like the decimal, like no rounding?
I rounded it.
All right, write your answers on your whiteboards when you're ready. Okay, can you round? Okay, and what did you enter your L1? Okay, let me see those whiteboards. What's your prediction in 2020? Yay, 9.54 seconds. Everybody got it. Awesome. Okay, did anybody watch the 100-meter dash in the Summer Olympics this summer? You did? Don't give it away. Do you know the time he ran it in? I have no idea. No idea. Okay, good. We're going to do the exact same thing, but we're going to do 2012 this time. Okay, does anybody know who the winner was? Yes. Bolt. Bolt's the one that ran it. I want you to predict what he won gold as this time. Do your prediction for what Bolt ran the 100-meter dash in at the Olympics this summer. Not yet. Let everybody do it. When you get it, put it on your whiteboard. And round to the hundreds. Hold up your boards. Can anybody do a drum roll? Because I can't. Awesome. Ready? Whoa. Exact. Exact. Isn't that cool? Kind of neat? Okay, I want to talk about our data and the future. Okay? Now, your original data, if we go back and look at that, your original problem, right? What's the trend starting at 1900 to 1996 and even going to 2012? What's happening to your winning time? It's decreasing, right? So it's going down. So I want you to think for a second how long that trend could continue. Could it keep decreasing and decreasing and decreasing? Thomas.
It might keep going down, but eventually there might be such a good time that's really hard to beat.
Exactly. Could anybody ever run the 100-meter dash in 0 seconds? No. So eventually, what's going to happen to your graph? It's going to level out. It's going to go horizontal. Would that change your correlation coefficient? Yes, it would. Okay, let's think for a second about who could use this data. Who could use information like that? What kind of career? Amanda?
People who are running against him.
People who are running against him. If you're going to prepare for the Olympics, you need to know how fast he's running. You need to know the trend of how fast people are running. Somebody else. Think of other careers, other people who might be involved. Donnie?
Vegas gambling.
Say that again.
Vegas gambling.
Vegas gambling. You need to know the odds. You got to know the odds. What about, think of a shoe company. Could they use it, like Nike?
Oh, yeah.
What could they do with it? They could name a shoe brand after the time. Think about maybe, Shelby?
They could try to create different types of shoes that are fit for that kind of speed.
Perfect. They could come up with a brand new shoe. Kelsey?
People writing an article for the newspaper about it.
Perfect. Absolutely. What about if you're a commentator for the Olympics and the race hasn't happened yet? Would it be nice to know what he might run it in? You could use that to predict it, right? Bridget?
People who are investing in him will want to know if he's going to do as good as he's projected to or if he's going off of his game.
Excellent answer. Very, very good. What about the health field? Okay, did anybody by any chance think performance enhancing drugs or anything like that? Yeah, a little bit. But even for the better, for health, okay, you could even, in the health field, maybe they could use this data. Okay, all right, we're going to do one more thing. This is your exit ticket to leave the class today. Okay, and this is by yourself, not in your group. I want you to predict what you would have to run the 100-meter dash in, and girls, just pretend like you're running in the men's final. Okay? What you would have to run in 2016 to win gold. Okay? And explain your answer to me. What time you would have to run it in, and then explain why you chose your answer. In order to win gold. In order to win gold. We're not going for the silver.
Are we writing on?
You're going to write on the exit ticket. You're going to write on the yellow. Oh. Okay. Explain why you're picking what you're picking. Nice. I like it. Did anybody write, there's no chance I could ever win gold? Because that's what I would have written. I can't even fathom running it like in 3 times the amount he ran it in. Nice, Ricardo. Okay. If you will collect your predictions in your group, and I'll come grab them for you before you leave.